Okay, get ready for this, because we are about to dive into a truly mind-bending idea. What if there's a single, hidden set of rules that governs everything? I'm talking from the most abstract math problems to the actual structure of the cosmos. It sounds completely impossible, I know, but stick with me, because this is one wild ride. I mean, it sounds like the setup to some kind of cosmic joke, right? On one hand, you've got a jumbled mess of string, a problem for pure mathematics, and on the other, a magnificent swirl of stars and dark matter, a problem for physics. But what if they're actually two sides of the very same coin? That's the huge mystery we're going to try and unravel today. You know, for centuries, science has basically built a giant wall right down the middle of reality. Over here, you've got the world of math. It's abstract, it's formal, it's all built on pure logic. And over there, you have physics. It's physical, it's messy, it's built on what we can actually see and measure. But the paper we're exploring today argues that this split, this wall, has caused us to miss a massive part of the picture. All right, so our first clue is hiding in a place you might not expect. It comes from the purely abstract world of mathematics and from the surprisingly deep study of, well, knots. So in the world of knot theory, the whole goal is to take a tangled mess and figure out what it really is, to find its true identity. And the simplest, most fundamental identity of them all is this right here, the unknot. It's just a perfect, simple loop. You could think of it as the ultimate ground state, the point of perfect symmetry that every other, more complicated knot gets compared to. So how do mathematicians actually identify a knot? Well, it's pretty wild. They've developed what you can think of as a mathematical machine. You feed any tangled up mess you want into this thing, and the machine just ignores all the superficial twists and turns. It processes the knot and spits out its core identity, a unique signature called an invariant that never ever changes, no matter how much you deform the loop. And what's amazing is that this isn't random at all. Mathematicians can measure, with incredible precision, how complex a knot is just by how far it deviates from that perfect, simple unknot. And these deviations, they're not chaotic. They are organized into this beautiful, structured hierarchy. Seriously, think of it like a ladder. Each rung you climb up represents a more complex and a less symmetrical knot. Okay, so hold that thought about a perfect baseline and structured deviations. Now, let's zoom way out from our little shoelace to the entire universe and ask a very, very similar question about symmetry out there in the cosmos. Now, this is one of the absolute biggest questions in cosmology. It's basically testing Einstein's equivalence principle on the largest scales imaginable. Does gravity pull on everything the exact same way? Or does dark matter, that mysterious stuff that makes up most of the universe's mass, does it follow a slightly different set of rules? To test this, scientists use a parameter they call gamma. And you can think of gamma as this little cosmic knob that measures any wobble in the symmetry of gravity. If gamma is exactly 0, the symmetry is perfect. All matter, dark or normal, falls identically. But if it's anything other than 0, it means some new, unknown fifth force is out there messing with things. So, what have we found? When we look at how galaxies are moving, how light bends around them, our best observations show that gamma is incredibly close to 0. I mean, it's not perfectly 0, but it's constrained to this tiny, tiny window. So just like with the knots, the physical universe seems to be clinging to a state of almost perfect symmetry. So let's just recap for a second. We've got a clue from pure math, a baseline of perfect symmetry, the unknot, and a structured way to measure any deviation from it. And we have a clue from physics, a baseline of perfect symmetry, gamma equals 0, and a way to measure any deviation from it. The paper we're looking at proposes one single, powerful theory to explain both of them. This right here is the core idea. The paper introduces a framework called the theory of infinity, or TOI, and it argues that the patterns we're seeing in math and in physics, they're not just similar, they're not just analogous, they are direct manifestations of the exact same underlying process. And this is where it all clicks together. The theory of infinity is basically a universal translation dictionary between these two worlds. That mathematical machine that identifies knots, the theory says it's the same kind of thing as the law of gravity. They're both what it calls a symmetry operator, a fundamental rule that sorts reality. And that perfect unknot, it's the exact conceptual parallel to gamma equals 0. They're both a perfect symmetry point, a baseline of pure stability. It's a stunning, absolutely stunning one-to-one match. So how does this actually happen? The theory proposes it's all driven by a simple, repeating loop. So imagine you start with this chaotic sea of possibilities, all potential knots or all types of matter. Then, a universal rule of symmetry acts on that chaos, almost like a filter, and it creates a stable, identifiable structure. And here's the real kicker. That new stable structure becomes the new, more orderly starting point for the next loop. It's how complexity literally builds on itself, step by step. So if the same generative loop is shaping both abstract ideas in our minds and the actual physical fabric of the universe, what does that mean for us? I mean, what are the implications? Let's unpack this, because it's incredible. Well, this is a profound shift in thinking. It suggests that abstract math isn't just some clever game we invented. It might actually be the literal language of reality's fundamental symmetries. And the laws of physics, like gravity, they might not be these arbitrary rules, but the inevitable, stable outcomes of this universal process. And this means that if we do find new forces out there, they won't just be random. They should appear in a structured, predictable hierarchy, just like the complexity of those knots. And crucially, this isn't just philosophy, it's testable science. The theory makes a concrete, falsifiable prediction. It says that if we ever detect a fifth force, a tiny non-zero value for gamma, its behavior, its structure, should follow the exact mathematical patterns that describe the next rung up on that ladder of knot complexity. The cosmos, in essence, would be performing a mathematical calculation right in front of our eyes. And that brings us to the final thought. If this single, elegant pattern of generating stable realities from a sea of pure potential really does shape mathematical knots and physical galaxies, it leaves us with one absolutely profound question. What else does it shape? Could this be the hidden rule behind biology, consciousness, even art? Our time is up, but the questions, I think, are just getting started.